Okay, so a major application that requires matrices and matrix arithmetic and matrix algebra is the Leontief input-output model. So this input-output model is basically modeling the flow of goods between sectors in an economy and how each sector requires the use of some goods from the other sectors in order to create what they're creating, and they want to possibly have some excess to meet outside demand and things like that. So our first example to introduce this is the idea that the coal industry, for example, supplies the steel industry with one of its main raw materials. But at the same time, steel, in the form of machinery, vehicles, and so on, is needed to mine and transport coal. So this constant flow of goods between industries characterizes an interacting economy and at the same time contributes to one of the main obstacles to effective economic planning. It says if we set arbitrary production goals for each industry, we may wind up with shortages. And a price increase is one key industry may send a ripple effect through the entire economy. So these are all good things to keep in mind as we do these. So the idea of the Leontief input-output model then is that it's a model of an economy with several sectors. Now we only deal with 2 or 3 because we want to keep things very basic, but you could certainly extend this idea 2, 4, 5, 6, even more than that sectors, which is more reality when you really think about the real world. Each sector is going to use some of the output of the other sectors. An excess is produced to meet outside demand, and each sector must produce enough to meet both the demand from the other sectors as well as the demand from the market. So we're going to consider a very highly simplified economy with 3 producing sectors: steel, coal, and transportation. So we're going to have C for coal produced, S for steel produced, and T for transportation produced or provided. So what we want to keep in mind as we go through this work is that when you are making or producing a commodity, that's when you use the variable. Because we're going to be, using some of a commodity to make another commodity, and it's when you are making that commodity is when that variable gets used. Okay, so let's see. Let's fill in these blanks below. It says to produce 1 ton of coal. So we are making then, we are producing coal or making coal. So we're going to use a C in all of these. It says the industry needs 0.02 tons of coal. So they actually need some coal to produce more coal. So they need 0.02 tons of coal. That gets a C with it because we are producing coal. How much steel does it need? It needs 0.1 tons of steel, but that also gets a C with it because, again, we're producing coal. And we need 0.3 units of transportation. So it may seem a little counterintuitive there that all of those get C's, but it's because we are making coal in that case. Now we're going to move on, and for each one in steel, we're going to produce 1 ton of steel. So again, producing steel. So every single one of these is going to get an S with it. We need 2 tons of coal, 0.01 tons of steel, and 0.05 units of transportation. So watch your 5s and your S's there. And then if we are going to produce or provide 1 unit of transportation, we are going to need, so these are all producing transportation. We need 0.01 tons of coal, 0.1 tons of steel, and no transportation. So they don't need any transportation to create transportation in this situation anyway. Okay, so that's the information we've been given. What you are going to be required to do in your work is create what we call an input-output matrix. So you're going to create this matrix that shows the production and the consumption of these raw materials. And what's really important is always when you're making these, whatever is producing goes as the rows over on the left, and whatever is consuming goes up on across the top as the columns. Okay, so if we kind of scroll back here, I'm going to create these as columns because we were creating, what were we creating? We were creating coal, then steel, then transportation. These are going to be our columns. When we were creating coal, we needed to use 0.02 of coal, 0.1 of steel, sorry, and 0.3 of transportation. So that's going to make my first column whenever I write this. So whenever I write this, to create coal, I needed, what's happening here? I don't need a box. Get away, box. Okay, so I needed it's because I'm trying a new way of writing here. I apologize, guys. Okay, let's get okay. So to create coal, I needed, 0.02 of coal, I needed 0.1 of steel, and I needed 0.3 of transportation. So I create my columns there. And then you can scroll back up. I'm going to mess up my screen if I try to do it. But to make steel, you needed 2 tons of coal, you needed 0.01 tons of steel, and you needed 0.05 units of transportation. And then to make transportation, we needed 0.01 tons of coal, 0.1 ton of steel, and no transportation. So what's important is that you're using this over here to make this, and that's how those input-output matrices are always created. Now, let's go down to a lot of times what you will see is a flow, a diagram of the sectors. And whenever you are drawing these, what's very important is that if the arrow is pointing to a sector, that's what the sector is consuming. So again, that is like the columns up here. And so whenever an arrow is pointing to that sector, it needs to have that variable in it. Okay, so I'm going to again have to sort of hide that in order to write on my screen. But if we go down our columns, to create coal, we needed 0.02 tons of coal. So because this arrow is pointing to coal, we needed 0.02 of coal going in there, coal to itself. Now the other arrows that are pointing to coal are this one. So how much was coming from steel? That was the 0.1. And again, it gets a C with it because it's pointing towards C. And then the last one is this one right here. So what was coming from transportation and going to coal, that was a 0.3. Okay, now I'm going to go look for all the arrows that go to steel. So the one that was coming from coal to steel was the 2. From steel to itself was the 0.01. And from transportation to steel was the 0.05. And again, all those get S's because they're pointing to the steel. And so finally, what's pointing to transportation? From coal to transportation was the 0.01 T. From steel to transportation was the 0.1. And from transportation to itself is nothing. So that is how we can make a diagram of what's going on in these economies.